With a hypothesis test, we have an option to use either the traditional methods or the p-value method. With the p-value methods, we compute the test statistics, and then from the test statistic, we find the corresponding p-value. And then we draw the conclusion based on the p-value. With the traditional methods, we use the significance level alpha. If the significance level is not given in the problem, we would use the standard alpha equals 0.05. Then we look up the critical values. For the z-test, the critical value will be z star to distinguish from the z-score. Or for the population mean test, the critical value can be either z star or t star. Note that for the mean, z star is when sigma is known, and z star is when sigma is unknown or not given. In some cases, it is more convenient to use the traditional methods because we do not have all of the t critical value on the t table. If we use a calculator, then it doesn't matter. For example, for the left tail test, remember that hypothesis test depends on sampling distribution, so we have a normal distribution here. With the left tail test, we use alpha to find the critical value z star or t star, and we shade the area on the left hand side. This area is called the critical region or the rejection region. Any test statistic that we compute that falls into this region, we would reject the null hypothesis. Again, this is what we call the rejection region. And for the left tail test, this means any test statistic z or t that is less than z star, we would reject the null hypothesis. For the right tail test, we would shade the area on the right hand side, and so using the significance level alpha again, we find the corresponding critical value. We shade the rejection region. Any test statistic z, or again for sigma unknown, we would use t. Any test statistic that fall into the rejection region, we would reject the null hypothesis. And for the right tail test, this means if any test statistic is more than the critical value, we would reject the null hypothesis. For the two-tailed test, we would split alpha into two. And we still have the normal distribution here. We split alpha over 2. So for example, if alpha equals 0.05, then alpha over 2 is 0.025. Then we would find the corresponding critical value z or t for alpha over 2. And so this is alpha over 2, and we would find the corresponding z star or t star for this alpha over 2. And now we have two rejection regions, one on the left and one on the right. We do not know which one. However, when we compute the test statistics, if the test statistic falls into any of the two rejection region, we would reject the null hypothesis. So for example, if we compute the test statistic z, and if it is on the left hand side of the z star on the left, then we would reject the null hypothesis. Similarly, if we compute the test statistic and it is on the right hand side of the right z star or t star, then we would reject the null hypothesis. And so the conclusion is about the null hypothesis here, whether we need to reject or fail to reject the null hypothesis. Now, the shaded region is called the rejection region. What that means is that if we compute the test statistic and the test statistic fall into the region that is not shaded, then we would fail to reject the null hypothesis.